When raceways containing ungrounded conductors of size 4 American wire gauge or larger enter a cabinet, box enclosure, or raceway, the conductors must be protected. This protection is achieved by using a substantial fitting that provides a smooth, rounded insulating surface. This requirement aims to prevent damage to the conductor insulation, which could lead to short circuits, ground faults, or other electrical hazards. The National Electrical Code, or NEC, specifically addresses this in Section 300.4 F, titled Insulated Fittings. This section mandates the use of insulated fittings or equivalent protection to safeguard conductors from abrasion and damage at entry points to enclosures. The primary reason for this requirement is to mitigate the risk of insulation damage during installation and operation. Large gauge conductors, particularly those of size 4 American wire gauge and larger, exert significant pressure on the edges of raceway terminations as they are pulled into enclosures or cabinets. Without a smooth, rounded insulating surface, the sharp edges of the fitting or raceway can easily cut or wear away the conductor's insulation over time. This abrasion can eventually expose the bare conductor, creating a potential safety hazard. There are some exceptions to this rule. One exception applies when the conductors are separated from the fitting or raceway by substantial insulating material that is securely fastened in place. This means that if you can effectively insulate the conductors from direct contact with the fitting or raceway using a robust insulating barrier, you may not need a dedicated insulated fitting. However, the insulating material must be securely fastened to prevent it from shifting or dislodging, which could compromise its protective function. Another exception exists for threaded hubs or bosses that are an integral part of a cabinet, box enclosure, or raceway. If these hubs or bosses provide a smoothly rounded or flared entry for conductors, they meet the intent of the code and eliminate the need for separate insulated fitting. The key here is that the entry point must be smoothly rounded or flared to prevent sharp edges from damaging the conductor insulation. It is important to note that conduit bushings constructed wholly of insulating material cannot be used to secure a fitting or raceway. While insulating bushings can provide some level of protection against abrasion, they are not designed to withstand the mechanical stresses associated with securing raceways. Therefore, they cannot be used as a substitute for a proper fitting. Furthermore, the insulating fitting or insulating material used must have a temperature rating not less than the insulation temperature rating of the installed conductors. This ensures that the fitting or material can withstand the heat generated by the conductors without degrading or losing its insulating properties. When selecting an insulated fitting, it is crucial to consider several factors. Firstly, the fitting must be appropriately sized for the conductors and raceway being used. The fitting should provide ample space for the conductors to enter the enclosure without being subjected to undue bending or stress. Secondly, the fitting must be compatible with the type of raceway being used, whether it is rigid metal conduit, electrical metallic tubing, or PVC conduit. Each type of raceway has its own specific fitting requirements. Thirdly, the fitting must be listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or UL. This ensures that the fitting has been tested and certified to meet applicable safety standards. When installing insulated fittings, it is essential to follow the manufacturer's instructions carefully. This typically involves preparing the raceway end by removing any burrs or sharp edges, applying a suitable lubricant to the conductors, and carefully pulling the conductors through the fitting. The fitting should be securely fastened to the enclosure or cabinet to prevent it from loosening or dislodging over time. In summary, NEC Section 300.4 F mandates the use of insulated fittings or equivalent protection for conductors of size 4 American wire gauge and larger entering enclosures or raceways. This requirement aims to prevent insulation damage and ensure electrical safety. While there are exceptions for situations where conductors are adequately separated from fittings or raceways by insulating material or where integral hubs provide a smooth entry, it is crucial to carefully evaluate each situation to determine the appropriate level of protection. Always consult the NEC and local electrical codes for specific requirements and guidance. In practical terms, this means that anytime you are running wires of size 4 American wire gauge or larger into a metal enclosure using a PVC conduit, you generally need to install a bushing on the end of the PVC connector inside the enclosure. This bushing provides a smooth, rounded surface that prevents the sharp edge of the conduit connector from damaging the wire insulation. The exception to this rule is when you can ensure that the wires are completely separated from the connector edge by substantial, securely fastened insulating material. However, this is often difficult to achieve reliably, making the use of a bushing the most straightforward and dependable solution. Failure to comply with NEC 300.4 F can result in code violations, potential safety hazards, and increased risk of electrical failures. Therefore, it is crucial for electricians and installers to be aware of this requirement and to take the necessary steps to ensure compliance. The specific type of bushing required will depend on the size and type of conduit being used. There are various types of bushings available, including insulated bushings, grounding bushings, and combination bushings. Insulated bushings provide a smooth, rounded insulating surface, while grounding bushings provide a means for grounding the metal enclosure. Combination bushings combine both insulating and grounding functions. When selecting a bushing, it is important to choose one that is listed and labeled for the intended application. This ensures that the bushing has been tested and certified to meet applicable safety standards. The installation of a bushing is typically a simple process. The bushing is simply screwed or snapped onto the end of the conduit connector inside the enclosure. It is important to ensure that the bushing is securely fastened and that it provides a smooth, continuous surface for the wires to pass over. In addition to the NEC requirement for insulated fittings, there are other code provisions that address the protection of conductors from physical damage. For example, NEC section 300.4 D requires that conductors be protected from abrasion where they pass through metal studs, joists, or rafters. This can be achieved by using grommets, bushings, or other approved methods. Similarly, NEC section 300.15 requires that conductors be protected from damage where they enter or exit boxes, conduits, or fittings. This can be achieved by using cable clamps, connectors, or other approved methods. By following these code provisions, electricians and installers can ensure that conductors are adequately protected from physical damage, reducing the risk of electrical hazards and ensuring the long-term reliability of electrical systems. Remember that the NEC is a comprehensive document and it is essential to consult the latest edition for the most up-to-date requirements. Local electrical codes may also have additional requirements or amendments to the NEC, so it is important to be familiar with the applicable codes in your area. Furthermore, it is always advisable to consult with a qualified electrical inspector or engineer if you have any questions or concerns about electrical installations. These professionals can provide expert guidance and ensure that your installations comply with all applicable codes and standards. They can help you navigate complex code requirements, select appropriate materials and equipment, and ensure that your electrical systems are safe and reliable. In conclusion, understanding and adhering to NEC section 300.4 F is crucial for ensuring the safety and reliability of electrical installations involving large gauge conductors. By using insulated fittings or equivalent protection, you can prevent insulation damage, reduce the risk of electrical hazards, and comply with applicable codes and standards. Always consult the NEC and local electrical codes for specific requirements and guidance, and seek expert advice when needed. This focused approach not only ensures code compliance but also contributes to a safer and more efficient electrical system. Now let's delve a bit deeper into the practical applications of NEC section 300.4 F and explore some common scenarios where this requirement comes into play. Firstly, consider a situation where you are installing a sub-panel in a residential setting. You need to run a feeder consisting of 4 American wire gauge copper conductors from the main service panel to the sub-panel. The conductors are routed through a PVC conduit that terminates in both the main service panel and the sub-panel enclosure. In this case, you would be required to install insulated bushings on the ends of the PVC connectors inside both enclosures. This will protect the conductor insulation from abrasion as the conductors enter the enclosures. Secondly, imagine that you are working on a commercial project involving the installation of a motor control center. The motor control center is fed by large gauge conductors that are routed through rigid metal conduit. The conduit terminates in the motor control center enclosure using threaded connectors. In this scenario, if the threaded connectors provide a smoothly rounded or flared entry for the conductors, you may not need to install separate insulated fittings. However, if the connectors have sharp edges or burrs, you would need to install insulated bushings to protect the conductor insulation. Thirdly, consider a situation where you are installing a generator in a backup power system. The generator is connected to a transfer switch using large gauge conductors that are routed through flexible metal conduit. The conduit terminates in both the generator enclosure and the transfer switch enclosure using squeeze connectors. In this case, you would typically need to install insulated bushings on the ends of the squeeze connectors inside both enclosures. This is because squeeze connectors often have sharp edges that can damage the conductor insulation. It is important to note that the specific requirements for insulated fittings may vary depending on the type of enclosure, the type of raceway, and the type of conductors being used. Therefore, it is always essential to consult the NEC and local electrical codes for specific guidance. In addition to the NEC requirements, some manufacturers of electrical equipment may also have their own requirements for insulated fittings. These requirements may be specified in the equipment's installation instructions or in separate technical bulletins. It is important to follow these manufacturers' requirements to ensure that the equipment is installed properly and safely. In some cases, it may be necessary to use special types of insulated fittings to meet specific application requirements. For example, grounding bushings are often used in applications where it is necessary to ground the metal enclosure to the equipment grounding conductor. These bushings provide a means for bonding the enclosure to the grounding conductor, ensuring that the enclosure is properly grounded. Similarly, combination bushings are often used in applications where it is necessary to both insulate and ground the conductors. These bushings provide both a smooth, rounded insulating surface and a means for bonding the enclosure to the grounding conductor. When selecting insulated fittings, it is important to consider the environmental conditions in which the fittings will be used. For example, in wet or corrosive environments, it may be necessary to use fittings that are specifically designed for those conditions. These fittings are typically made of corrosion-resistant materials and are designed to prevent the ingress of moisture. It is also important to ensure that the insulated fittings are properly installed. This typically involves cleaning the raceway end, applying a suitable lubricant, and carefully inserting the conductors through the fitting. The fitting should be securely fastened to the enclosure to prevent it from loosening or dislodging. Regular inspection and maintenance of insulated fittings is also important. Fittings should be inspected periodically for signs of damage or deterioration. Damaged or deteriorated fittings should be replaced promptly to ensure continued protection of the conductors. By following these guidelines, you can ensure that insulated fittings are properly selected, installed, and maintained, providing long-term protection of conductors and ensuring the safety and reliability of electrical systems. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. A qualified electrician can assess your specific situation, provide expert guidance, and ensure that all electrical work is performed safely and in accordance with applicable codes and standards. Moreover, continuous education is crucial in the electrical field. Staying updated on the latest revisions of the NEC, attending industry workshops, and pursuing certifications can significantly enhance an electrician's knowledge and skills. This commitment to lifelong learning ensures that electrical professionals are well equipped to handle the ever-evolving challenges of the electrical industry and maintain the highest standards of safety and workmanship. In summary, the proper application of NEC Section 300.4 F is not merely a matter of code compliance, but a fundamental aspect of ensuring electrical safety and system reliability. By understanding the requirements, exceptions, and practical considerations discussed, electrical professionals can make informed decisions and implement effective solutions that protect conductors, prevent hazards, and contribute to a safer electrical environment for everyone.